we're going to be talking about taking Kafka to the next level, utilizing Stream. So we're going to start off talking about what is streaming integration and processing, a quick overview of the Stream platform. Then we'll go into our particular solutions for Kafka, including some customer examples, what our differentiating features are. Then we'll do a 10-minute demo of how you can get data out of databases, put it into Kafka, do some integration processing on that and visualizations, ending up with a Q&A. So the first thing to bear in mind is that streaming data is kind of the natural way that data is supposed to be. It's kind of a quirk of fate, history, technology that we started dealing with data in batches. Data is not ever created in batches, but batch processing occurred because storage was cheap and memory and CPU was expensive. But now in a world where storage could potentially run out or be overwhelmed by the amount of data that we have, and memory and CPU has gotten a lot cheaper, which means that streaming in general and streaming integration has emerged and is now capable of being a major infrastructure requirement. It's not just enough, though, to be able to move data around. You also need to be able to collect it, process it, analyze it, visualize it, and deliver that data or the results of processing that data somewhere else as it's happening instantaneously. And to be able to do this by running something familiar, something that people can work with, like SQL, on that data in motion before it ever lands on disk, so to do the processing in memory. And this is all kind of part of modernization. Now, we have a number of customers, quite a number of customers that are modernizing. They're moving to new technologies. And they're not just doing that for the fun of it. They're doing it because there's this recognition that in order to ask the right questions of data, that data needs to be present in the correct technology. So it used to be in the old days that you would have data in a database and you put it into a data warehouse for analytics. But a data warehouse might not be the most appropriate technology for building machine learning models, for example. So you may want to put that data into Hadoop or push it into the cloud or into Hadoop on the cloud. You may want to utilize other technologies as well, like graph databases for making connections or in-memory caches, distributed data grids, in order to speed up applications. So it's important to be able to get your data in the right place, in the most suitable place. But it doesn't mean that you're ripping out or replacing legacy systems. These things may not be replaceable. They may take a long time to replace. We have customers that have databases that are 30 plus years old that are doing transaction processing. So in order to do analytics on something like that, and modern analytics on something like that, you need to be able to bridge the old and new worlds. And streaming integration is the foundation by which you can do that. It's the shiny glass and aluminum structure built on the side of the old castle of your legacy systems. A little bit about Stream. Stream provides streaming integration with intelligence, and we're founded in 2012. The four of us that founded the company, we came out of Golden Gate Software. We've been working in the enterprise middleware, enterprise data markets for a long time. We're backed by some really great investors, including Summit Partners, Intel Capital, Atlantic Bridge, and Dell EMC. And our customers range across most industries: financial services, telco, logistics, healthcare, retail, and IoT customers. Streaming integration. What is streaming integration with intelligence? Well, it's all about continuously, that's a very important word there, moving any enterprise data, ensuring that you can handle extreme volumes of data at scale with very high throughput, that you can do processing, analytics, and correlation of that data in flight, in memory, while it's moving before it ever hits disk, in order to make the data valuable, to extract the maximum value out of that data, visible so you can interact with it, and do this in a verifiable fashion. And companies are using streaming integration for lots of different use cases. We have customers that are taking data in databases and pushing it out onto Kafka. There are others that are using data in Kafka and doing analytics on it, or doing processing on data in Kafka. There are other customers that are using us for cloud adoption. So being able to go from an on-premise database into the cloud continuously in real time to keep that cloud database instance, whether it's Azure SQL DB or Amazon Redshift or Google BigQuery or any of the RDS databases, continuously up to date, so that it is always in sync with on-premise databases. And similarly with Hadoop, we work with all of the major Hadoop implementations, Cloudera, Hortonworks, MapR, and we enable you to collect data in real time, prepare it, get it in the right format, and then continuously deliver that into Hadoop. And then from there, you may be building machine learning models or doing deeper analysis on long-term storage of data. But of course, we also have customers that are doing real-time analytics. So these customers are using streaming integration to not only collect and move data in real time and process it in real time, but also to visualize it, to interact with it, and to spot anomalies, to make predictions, to send alerts, and to visualize this in dashboards. And then we have customers on the Internet of Things side wanting to do edge processing on large-scale data. And that edge processing actually also holds true for things like security data, large amounts of security logs being generated within the enterprise. So edge processing and also analytics on the edge and analytics in the cloud for IoT. So streaming integration can be utilized for a large number of different use cases. And we'll talk about some of those in more detail, and we'll also talk about now the Stream platform and how the Stream platform provides all the aspects of streaming integration. This is kind of how streaming integration is defined with intelligence, and what the pieces are and the pieces that Stream provides. So the first piece of streaming integration is being able to continuously collect data. So being able to get the data wherever it's generated within the enterprise and turn that into streams of data. Now, with things like sensors and message queues like Kafka, they push you data. So that's kind of streaming already. But with real-time, getting real-time data out of things like log files, you can't treat those as a batch. You have to continuously read at the end of the file. You have to handle file rollovers. You have to be able to deal with parallel reading of multiple files across multiple servers. As soon as new data is written to any files, you're streaming that out and turning that into a data stream. Similarly with databases. Databases are thought of as a historical record of what happened in the past. In order to get real-time data out of a database, you need to use a technology called change data capture, which listens to the database log, sees the inserts, updates, and deletes as they're happening with the database, and streams those out in real time. So now once you get past this continuous data collection, you have real-time data streams. Those real-time data streams can be used to move data anywhere within the enterprise or cloud, and then delivered to continuously to a variety of different targets. And this is kind of a mix and match. It's like a big bag of multicolored Skittles. You can go from databases to Kafka. You can go from Kafka to the cloud. You can go from log files into Hadoop. It's very varied what you can do here. But this is a simple case. One source, one target. You're delivering whatever's created in real time continuously from one side to the other side. And pretty often, that is utilizing Kafka in some way to distribute data around an enterprise. And that can be our built-in Kafka, that we have Kafka built into the product. We actually have two ways of moving data around in the product. We have our own in-memory high-speed message bus that is in memory only, so it's very, very fast. And then we also have Kafka. And Kafka is a persistent message bus, but it does I/O. So typically, you don't want to use Kafka between every piece of stream processing. That would slow things down because you're doing particularly unnecessary I/O. So mostly, our customers will use Kafka close to sources to create a persistent, rewindable data stream that you can use for multiple applications. And then most of the rest of the processing will be in memory only using our own streams. And we'll see in a little bit how you can easily turn that on within the platform. But typically just moving data around isn't enough. Most of our customers are doing some degree of in-memory stream processing. And this is through a SQL-based language. It's a big extension of SQL. It's very rich. It includes time series capabilities. It includes Java capabilities and other extensions. But at the core, it's SQL, so it's very easy to understand, easy to work with. And that allows you to do things like filtering, aggregation, enrichment, and transformation of data as it's moving through the platform. And this isn't just a single query applied to a source. This can be an entire complex pipeline of processing that you're doing before you're delivering potentially to multiple targets. On top of this, we can do more advanced analytics types of functionality that bring intelligence. So these are things like correlating data, multiple data streams in real time, being able to kind of do advanced versions of that through complex event processing where you're looking for sequences of events over time, and statistical analysis, anomaly detection, that kind of thing. And this can be visualized. We have a built-in dashboard builder that allows you to build visualizations and also generate alerts and send alerts within the enterprise. The platform can integrate with other things as well. So we have seen integrations with machine learning and Neo4j, for example. And it's all done in an enterprise-grade way, an enterprise-grade platform that is inherently distributed, scalable, reliable, and secure. And the Stream platform integrates with a lot of different things. These are a list as of when we created this slide of sources and targets within the platform. So you can see it's a pretty varied bunch of things that you can read from on the continuous ingestion side and deliver to on the continuous data delivery side. Also supporting a lot of different formats. So out-of-the-box support for things like Apache access log or event logs or system logs that you just configure a reader, say it's that type of log, and away you go. You already have the ways of parsing that data. And similarly on delivery, there's lots of different varied ways that you can deliver, supporting things like delimited data, JSON, Avro, XML, etc. Supporting sources and targets across the enterprise and cloud. You can go to our website for a full up-to-date list of the sources and targets. They get added to during almost every release of the product. This is what the data flows look like within the platform. So data flows, you read them from the top. You can have multiple sources in a single data flow. Each step of the way, you can be doing some processing. That processing is through a SQL-based language, as you can see. It's very easy for anyone that understands SQL, whether they are developers or business analysts, data scientists, to actually build this out. And of course, you can build extensions to SQL, and that's pretty often where the developers that write Java code, for example, can come in to add business-specific functionality that may be written in Java, for example, into our platform and call that directly from our SQL. Similarly, dashboards can be built very easily. Drag and drop visualizations into the dashboard, configure them with a query, and know that visualization is showing real-time data. So let's talk about Stream for Kafka. Kafka by itself is not a destination or a source, it's a road, right? It's for moving data around. In order to make use of it, you need to be able to push data into it, you need to be able to take data out of it, you need to be able to do some kind of processing on that data and visualize and surface that in some way, and do this in an enterprise-grade fashion, right? Now, the way of doing that with Apache Kafka would be through the various APIs. So there are lots of different APIs that allow you to produce data, consume data, process that data, and configure it. But that involves a lot of developers, a lot of coding, a lot of knowledge. And you're still kind of just building a platform around Kafka as opposed to typically building the applications, because you're going to put your own framework in place. It doesn't have to be this hard. What we have done is surround Kafka with the Stream platform by being able to do the ingestion and pre-processing of data, so all collect from all those sources and deliver into Kafka. Be able to take data out of Kafka, do further processing, preparation, formatting, and then deliver where it needs to go. be able to do analytics on top of Kafka, so things like the correlation and complex event processing and anomaly detection and integration with machine learning, and visualize that through dashboards. And crucially, this can be done through a drag-and-drop UI. We also have a scripting language for those people that like working with VI and text, but you can build these applications very quickly using our UI, allowing developers to focus on business value as opposed to kind of reinventing the wheel and building all of the platform components that become part of our platform. Now, Kafka is built into the Stream platform. You can start a Kafka broker or set of brokers during installation process, and then very easily you can switch any of our streams from being a in-memory only high-speed stream to being a Kafka stream just with a click of a switch in the UI or a keyword in the scripting language. So we run on top of Kafka. We allow you to take data from any source, put it into Kafka. Kafka is both a source and target within our platform and also built into our platform. So here's some customer examples. We have a leading credit card network that is using Kafka as a real-time security hub. And that's where all of the activity around security analytics is taking place. So they're using Stream to ingest logs from a huge number of different security devices, correlate those in memory, so joining them potentially on things like your session ID or IP address, in order to join together records. So, for example, you might want to say, I want to join all of the activity from each IP address across all the different logs within 1 second and push that out onto Kafka. So you already have these correlated joined records that are much richer than the original raw data. That allows you to spot, for example, IP addresses that are doing bad stuff really quickly. But then they're also taking the data off Kafka, doing more processing on that, more analytics, then pushing the results back onto Kafka and to multiple other targets, and doing in-memory analytics and visualizations on that data. And they're running at around 20 terabytes a day right now of security data. Another example is this media technology company. They are doing change data capture from Oracle and SQL Server databases and doing processing on that and pushing that out onto Kafka. Also reading some data from Kafka as well and doing additional processing and pushing that out in Kafka. They're doing encryption on the data as it's moving. And this is all to enable their line of business people to be continually up to date what's happening with customers. It's all about customer service, making sure that you can have continually up-to-date data in the cloud, serving the line of business. And a final example is this online retailer. They already had website data on Kafka, and they're using us for real-time analytics and dashboards. And the great thing about this was the engineers responsible for this, they just downloaded our product, and they wanted to show the value of this real-time data that they had on Kafka. So they built some dashboards really, really quickly as justification to their management that they needed budget for the project. So that really increased the productivity of their teams and gave them insights into kind of what was happening in real time. The key things around Kafka are that you can expand the reach of Kafka, you can expand the type of data that you have on Kafka by ingesting data from any relevant enterprise source and pushing it onto Kafka. You can put it in the right format and pre-process it without having to do extensive coding, and get insights into Kafka through analytics immediately, generating alerts, visualize the data on Kafka very easily, and deliver data and insights that you got from that data from Kafka to any enterprise or cloud target. So key features are that we have this SQL-based development language. It makes it much easier to work with the platform. Of course, that frees up developers to do real business-specific value add as opposed to reinventing the wheel on platform tasks. So people that know the data can work with the data. You can do in-flight enrichment of the data using built-in cache. We also have time series analysis and time windows And we do guarantee exactly one's processing of data, even with relatively complex data flows that may involve time windows and complex event processing and other things that store things up. That means that every source event will be processed once and only once. This is part of our enterprise-grade promises. It is inherently distributed and plus a scalable architecture that automatically self-heals and automatically parallelizes its use of Kafka. We have this change data capture capability to get real-time data out of databases through the inserts, updates, and deletes as they're happening in real time. You can do these in-memory joins and correlation of data, not just on Kafka, but from any of the other sources that we have as well. And the built-in analytics and visualizations that allow you to go to the next level. And just an example of how we continually enhance our work with Kafka. In the last release of the product, we added this ability to scale the delivery or writing into Kafka even more. You could already scale by adding additional nodes. Now you can scale by using multiple threads within each single node of stream to write in parallel across multiple Kafka partitions. And similarly, on reading Kafka, as you scale a stream cluster, will automatically map out the partitions so you can scale reading from Kafka. We added in our own monitoring of Kafka metrics so that it helps you pinpoint issues and bottlenecks in Kafka itself as opposed to just within our product. And obviously, we're continually supporting new versions of Kafka as they're being deployed in customer sites. This is kind of what some of the Kafka monitoring looks like, and we have more detailed drill down on this as well. So you can see how many acknowledgements there were, the average time between calls, how long it's taking to do various things with Kafka. And this helps our engineers support really target bottlenecks and see, is this a problem in the way you configured an application? Is it a problem in the way you configured Kafka? Can we help you with that? Can we help you get better performance? So now we'll go into a quick demo where we'll walk through building things within the Stream platform. And we're going to start with doing change data onto Apache Kafka. So the way this works is you start by choosing a template. And the template is going to define source and target. We're going to go from MySQL into Kafka, but we also support MS SQL and Oracle and HP Nonstop and MariaDB for change data capture. We'll create an application, and now we'll configure how to connect to the database. So you enter the properties on how to connect to the database, and then we'll actually look at the database and see, is it ready for change data capture? If it's not, we'll tell you how to fix it. So once you've done that, you then select the tables that you're interested in doing change data capture on, and that will build data streams that include the change for all those tables. Final step is configuring Kafka. So you choose what topic you want to write to, where Kafka is, and also what format. We're going to do this in JSON. So we configure the writer to write in JSON onto Kafka. And once we save that, that's going to create a data flow. And the data flow, in this case, is very simple. We're sourcing from change data capture, and we're writing into Kafka. We can test this out by deploying the application that turns this definition into real runtime objects, and starting it, which will start things in the correct order so you don't lose any data. And then take a look at the data stream. So we take a look at this data stream, you'll see the raw change data that we're getting from the database. Both this is updates, you can see the real data, and you can also see the before image and a lot of metadata. But pretty often, you don't just want the raw data pushed out onto Kafka, you want to do some processing on it. So the first thing we're going to do is extract some of the fields, and we can do that by adding in a query. So we'll add in a continuous in-memory SQL query that is going to do some processing. And initially, we're just going to extract the major fields from the data and one from the before image as well. And that then is now, you can see it's very different to what we had before. it's basically just the raw fields that we chose, not all the rest of the metadata and everything else. We can modify the Kafka writer now to read from that instead of the direct change data capture. And now we have this linear flow where we're doing change data capture, we're processing it, and now we're writing to Kafka. We may also want to enrich it, so we're going to add a in-memory cache, in-memory data grid, that's going to contain some reference data. In this case, we're going to load product info, reference data from a database by specifying the data type that matches the database table. We're looking up by product ID, and then the database configuration, it's getting MySQL, and what the query is. We'll save that. Now we have a definition of this in-memory cache. We can utilize this cache to do enrichment. So we modify the SQL here to join with the cache in real time. And now you can see the data here includes the description and brand and category from that in-memory cache. And that was kind of how easy it was. Everything is through SQL, makes processing the data, enriching it very, very easy. Now what we're going to do is take that data that's been written to Kafka, and we're going to do the reverse. We're going to use a Kafka reader. So imagine you already have data on Kafka. Use a Kafka reader, potentially do some processing on that data, and then write that out to some of the targets that we support. So we'll add in the Kafka reader, we'll configure it with the same configuration as we use for Kafka writing. And we know that it's in JSON format, so we'll use a JSON parser, and we'll put that into the data stream. So now if we start this up, what you'll be able to see is that this is the JSON version of that data that we created in the previous step, including the enrichment from the cache. Now we can write a query that's going to pull data out of JSON. This is where some of the extensions of the platform come in. You don't just work with tuples within the platform, you can work with nested structured data like JSON. You can see here we're getting JSON values and turning those into stream elements. So now if we run this again, you can see we've now pulled out all the bits of the JSON into individual fields within the data stream. So that's kind of what the first part of the processing is. Now we're going to take that data and we're going to write that out to a file. So we'll connect in a target, and we're going to write it out in a delimited form. And default for delimited is the CSV format, which can be read by things like spreadsheets. So we configure where we're going to write the data, what the format is, and then we can save that out. And when we start up the application now, that data is going to be continuously written to a set of rolling files roll based on the file rolling policy. We can open that up in Excel, and we can see the same data that we were just looking at in the preview in the Excel document. Of course, that's just one example, right into a file. You could also use the same mechanism to write to things like Hadoop and the cloud. So we're going to add in connection to Hadoop. We're going to firstly put in a query that is going to limit the data we're writing to Hadoop. We're just filtering here. We're going to filter out everything apart from location 10. And now we're going to use a Hadoop target. And so we'll choose the Hadoop target, drag that into the data flow, and then configure the connectivity. You can see it's all the usual things that you'll be used to if you're writing things into HDFS. We're going to write in Avro format, and in Avro format you can specify the name of a schema file that you want us to generate that tells someone else the structure of this data. Save that out, and then if that was started, you would be writing data to Hadoop as well. But we're just going to show you now also how you'd write data to, say, Azure Blob Storage, drag in the Azure target, this time straight from the pre-processed data stream. We're going to get the configuration for the Hadoop Blob Storage, for the Azure Blob Storage from cloud, enter the configuration information. We want this to be written out in JSON. Now when you deploy this and start this running, you're writing to Hadoop and the file and the cloud. So now we're going to start looking at some more analysis. In this case, what we've done is we've put in an application that's reading weblogs in real time. It's doing some processing on those weblogs, again through SQL language, and writing that weblog data out to Kafka. So imagine this running on weblogs across multiple servers. You're turning that into a real-time, continuous web stream. So if we start this up, you can see this is kind of what the data looks like. You have things like IP address, what the request is, and then some things we pulled out of the URL to make processing easier later on. So now what we're going to do is use that weblog data, and this is quite a complex application. It's taking the data from Kafka, it's extracting all the key values, and then it's putting it through a whole bunch of analytics. It's doing time series analysis, it's grouping the data together, it's slicing and dicing the data over multiple variables, and it's doing all of that in real time. So you can utilize that processing and that type of analytics for alerts and writing out things, but also for visualizations. This is an example of a dashboard in our platform. It's visualizing that data that was on Kafka. You can drag and drop visualizations into the dashboard, configure them with queries, and then you have a full, rich, real-time streaming dashboard built on the back end. And these are some additional visualizations and analytics applications we've built, looking at things like security in factories, transaction data monitoring in real time, making predictions based on current values in a machine learning model, monitoring traffic through an airport in real time. So that's a very quick demo of some of the things that you can do and how easy it is to work with Kafka. If you want to know why you want to use Stream for Kafka, it's because we were designed for real-time data and for business-critical real-time data as a distributed clustered in-memory platform that has HA scalability, exactly once processing guarantees built into it. It's designed out of the box for working with Kafka data. It can deliver you very immediate ROI. You can get up and running very quickly. You can start providing value almost straight away. And you can build multiple use cases and multiple applications and data flows within a single cluster of Stream. And allows you to get operational value from the data while it's still relevant, because data can lose value very quickly. And also utilize the people that know the data scientists, business analysts, to work directly with the data through SQL, allowing developers then to focus on adding business value with specific algorithms and coding. And of course, it is easily extensible, integrates with a lot of things, machine learning and any other technology choices you may have made, and we're continually increasing the sources and targets that we support. This helps you speed your time to market and speed building things out that provide value to your business. Taking real-time data that is on Kafka or putting real-time data on Kafka can help your business work much more quickly. It is designed to be an enterprise-grade solution that you can trust with mission-critical applications and reduce the total cost of ownership of applications, because not only do you not need a lengthy development effort or evaluation effort for putting lots of bits and pieces together on top of something like Kafka in order to get value. You just need one vendor to support that. So it's very easy to iterate and build out new applications. Now, Stream is recognized as not only a cool vendor and an innovative vendor, but we're actually a really great place to work as well. We're very proud of awards that recognize that. So if there's a few things to take away from this presentation, it's that you can use Stream to ingest data into Kafka from virtually any enterprise source continuously. You can use Stream to pre-process and prepare data for different users and different targets. You can analyze and visualize data running in Kafka. You can deliver data from Kafka to enterprise and cloud targets. You can keep those continuously up to date, all while using an enterprise-grade platform, which is an end-to-end solution, enables your developers to focus on adding business value. So to get started, you can go to our website, you can read more, you can watch videos that we have on getting the most out of Kafka and everything else, a lot of different use cases as well. and feel free to interact with us. So let's see. We're at 11:36. Catherine, do you think we have time for some questions?
Yes, we are at the bottom of the hour, so if for those who can stay on, we'll go ahead and answer a few questions. I'll go ahead and jump right in. The first question is, how does Stream handle highly sensitive data? Does it encrypt data before moving?
So, of course, as with everything, you have options. But yes, Stream can encrypt data across data streams. They can be our own internal in-memory data streams. They can be Kafka data streams. In fact, we had security on Kafka before Kafka had security on Kafka. If you remember, there was no security in version 0.8 of Kafka. So we can protect any data stream within our platform through a role-based security policy that allows you to work with the results of processing of a data stream, but not actually get to or see the data on a previous stream. You can turn on encryption in the UI or through the scripting language just with a simple flag. That works both on our own in-memory streams and also on Kafka. So it's very easy to secure things down. We've also very recently added in some data masking capabilities that enable you to mask sensitive data as it's flowing through the platform in real time as well.
Great. Our next question, does it run on-premise only? If not, what cloud environment does Stream run on?
So Stream runs anywhere that you have a JVM, right? So it can run on on-premise servers, it can run in cloud servers, it can run hybrid across the two. It can run on VMs, it can run on physical machines, it can run on laptops even. In fact, a lot of people test things out on laptops. As far as supporting cloud's concerned, we are in both the AWS and Azure marketplaces. You can spin up instances there. You can also ask us for images that you can spin up in those clouds. So you can give us a try in the cloud or on-premise. It's up to you.
Thank you. How is change data capture from database handled? How do we configure the parameters on which the change data has to be captured?
So I know we stepped through the wizard pretty quickly, but as you are configuring that, you can choose what tables, what columns from what tables, and that is going to work with the database in the right way, using the correct APIs, etc., to be able to turn on and access change data capture for those particular tables that you've selected. So that's kind of the first step, is saying, what data do I want to collect? But if you look at replication solutions, then they will basically just say, okay, you can do change data capture from one database and deliver that change into another database. But they're not streaming integration solutions. So Stream is a full streaming integration solution. So we don't just do the change data capture and the change delivery. You can also do a lot of processing, the filtering, transformation, enrichment, correlation, do all of that in memory with those data flows that I showed you, which you can build through the drag and drop UI or through the scripting language. You do all of that processing in memory before you deliver things out. So it's a much more flexible solution that allows you to get exactly the data you want wherever you want in your enterprise or in the cloud. If you're working with change data capture, we have customers using change data capture for delivering on Kafka, but also for cloud migrations, also for data replication, data consolidation, very many varied use cases.
Great, thanks, Steve. I think I understand what this question's about. Does HA capability require that the Stream project be enabled by Kafka?
I'm not quite sure what I think that's about.
Yeah, we might take that one offline.
Yeah, we'll think about that one and see if we can pass it.
Okay. Let's go. And one more. How does Stream support exactly once processing when there are time windows?
So the way that Stream deals with recovery in general and ensure that if you have a system outage, you don't lose stuff, is through a consistent checkpointing mechanism across an entire cluster. And this enables you to recover state by rewinding into sources and rebuilding that state. Now that can be quite a complex task, because not only do you need to know the earliest point you have to go back to rebuild the whole state, but you also need to be able to know, have I already emitted results? Because I don't want to have more than one result, because that's not exactly once, then that's at least once. You need to know, have I already generated results for this data as I'm rebuilding state, and know that for every output. So it's quite a complex thing to actually achieve, but we have achieved it.
Great, thanks so much, Steve. In the interest of time, if we did not get to your specific question, Steve will follow up with you directly via email within the next few hours. On behalf of Steve Wilkes and the Stream team, I'd like to thank you again for joining us today. Have a great rest of your day.